Hello everyone, welcome back to the playlist of numerical methods. In the previous lectures, we have understood what is trapezoidal and Simpson's rule. In this video, we will try to code trapezoidal and Simpson's rule in MATLAB. Let us quickly recalling what is trapezoidal and Simpson's rule. For trapezoidal rule, we have defined the trapezoidal rules formula in the form this, and for Simpson's 1/3 rule we have defined the formula as this. Before starting the MATLAB code, let us take an example. This question have been solved manually in the previous video. If you want to understand how to solve this question with the help of trapezoidal and Simpson's 1/3 rule, do check out that video. Quickly starting the MATLAB code. Firstly, defining the function we want to integrate. Let this be the variable f using the input function to enter and in this question we have used the function as 1 upon 1 plus x square, so it will be inputted as @x because it will be a function of variable x. 1 dot divided by 1 plus x dot power 2. Remember that you have to use dot here because we are going to use element wise product here or division. After that we will define the limits of integration. Lower limit will be stored in the variable a and upper limit be stored in variable b. Now defining the number of subintervals which is stored in variable n, and in the given question we have the lower limit as 0 and upper limit as 6. Taking the value of h as 1, we have divided this interval into 6 equal parts. So the value of n will be 6 again. Calculating the step size, which will be h is equals to upper limit minus lower limit divided by n. After that we have to create the values of x and evaluate the function at these x values. For creating the x values, as x is equals to initial point, which will be the lower limit, step size, and terminating point, which will be the upper limit. After that we have to evaluate the function at these x values using y is equals to f of x. I am not putting semicolon in the end of these statements so that the values of x and y should be printing on the command window. And for applying the trapezoidal rule, integral value is equals to h by 2 into f of a plus 2 times sum of y starting from 2 with increment 1 till end minus 1 plus f of b. To display the results using printing statement as f print f, the integral value using trapezoidal rule is percent f comma integral value. Let us try to understand this code. Firstly, we have inputted the value of f, a and b, and after giving the value of n as 6, the value of h have been calculated as 1. Now to create the values of x, we have 0, 1, 2, 3, 4, 5 and 6. Now evaluating the function f at the corresponding values of x, we will get the output as 1, 0.5, 0.2, 0.1, 0.0588, 0.0385 and 0.027. This will be the corresponding value of y with respect to x. And initializing the sum value as 0, we will directly apply the trapezoidal's formula, and by trapezoidal's formula we are required to find out the integral value 1 upon x square from 0 to 6, and the trapezoidal formula will be h by 2 into y0 plus 2 times y1, y2, y3, y4 plus y5 plus y6. The corresponding value of y0 is 1 and y6 is this. Rest of these terms are here. So for the trapezoidal's formula, we will use h by 2 into f of a. We can also use y1 here, which will be same as this point. After that, we have to find the sum of the between terms and multiplied by 2. For that, we will use the variable sum of y starting from point 2 with the increment 1 till end minus 1, which will be y5, and after that adding the last term, which is y6, and we can also use the term here as y end, which will give us the final result as 1.4108. I hope this MATLAB code is clear to you now. On the similar lines, we will try to code Simpson's method, and I will make the editation between these lines of code so that you can understand what is the basic difference between trapezoidal and Simpson's methods MATLAB code. We will define the function and limit of integration in the same way as we have done in the trapezoidal's method, and then we will define the number of subintervals. But in Simpson's rules, there is a restriction over the value of n, that is, the number of subintervals must be even for this rule. So we will add one condition here, that if the modulus of n comma 2 is not equals to 0, then there will be an error which will say the number of subintervals must be even for Simpson's rule. and the loop will end. After that, we will calculate the step size in the same way and define the values of x with that height h and the corresponding value of y. You can skip this initializing the sum as 0 and directly applying the Simpson's 1/3 rule, which will be h by 3 into y1 plus 4 times sum of y starting from 2 with the increment 2 till end plus 2 times sum of y starting from 3 with the increment 2 till end minus 1 plus y end, and we will display the integral value of Simpson's rule in the same way. Now let us understand this Simpson's rule first. When we are solving this method manually, we have seen that integral value according to Simpson's rule is h by 3 into y naught plus 4 times the odd terms and 2 times the even terms plus the last term, which is y6. Y naught value is here as 1 and the last term here is this. Now we need to add the odd terms. The odd term here is y1, y3 and y5, where the even term here are 0.2 and 0.0588, which will be added here and the odd terms will get in here. Using h by 3 into y1, which will be 1, and y end, which will be 0.027, and let us understand this term first, which is y of 2 colon 2 colon end. Understand that this end value will be 6. Y is a vector here and it will take the second position in that vector, which will be 0.5. With the increment of 2, it will take the next value as 0.1 and the last value as 0.0385. And if we put the sum in front of it, it will simply add these values. Similarly, when we will use y3 colon 2 colon end minus 1, it will go to at index 3 is 0.2 and with the increment of 2, the next value is 0.0588, and if we add the sum in front of it, it will add these values. Finally, the integral value will be calculated and it will give the output as 1.3662. I hope this MATLAB code is clear to you now, and if you have made an understanding of this code, then do try some practice questions which are shown on the screen, and there are also some questions discussed in the previous video. You can also use these questions to check if your MATLAB code is working correctly or not. Link to that video is added in the description box. If you still have any doubt in the MATLAB code or any statement of line, do let me know in the comment sections. And if my videos are helping you, don't forget to share it with your friends. Happy learning!